This video is the second video on converting forms. This video is going to cover how to change quadratic function from standard form to vertex form. And there's a typo, so we can change that. It's not from, it's form. Why would we need to do this? Well, mainly because vertex form is a lot easier to graph from. Once we have it in vertex form, we know what the vertex is, we do our counting 1, 3, 5, and it's easy to graph. Well, how do we do that? This method is called completing the square. And basically, to have a vertex form of an equation, you have to have a perfect square trinomial. And so that's what we need to do, is complete the square, that is, finish out the trinomial so that it's a perfect square. How do we do that? Well, a couple things. First of all, take a note out here on the margin. This is the rule that we talked about a couple days ago, that a plus b quantity squared is equal to a squared plus 2ab plus b squared. And so we're going to take that rule and figure out, well, how do we get that last term? Well, if there is no leading coefficient, if there's no number in front, it's just a plain old x squared, then it is slightly easier than the other way. What we do is we divide 8, divide by 2, and that's 4, and 4 squared is 16. So that would be a perfect square trinomial, because if we wanted to factor that, it factors into a perfect square, factors into x plus 4 quantity squared. So that's what we're doing. We're trying to create a perfect square trinomial, and right now we're just trying to get the pattern in our brain of how do we even do this, and then we'll use it in the next section. Okay, so the next one, x squared plus 12x plus blank. Do you know what would go in that blank? Well, we take half of 12, which is 6, and we square that, and we come up with 36. And once again, that is a trinomial that can be factored into a perfect square. Okay, take a second to look at C and try that on your own. See what you think it would be. Okay, half of 18 is 9. 9 squared is 81. Now, there is a negative there, but negative 9 to the second power is positive 81. If your negative is inside those parentheses, negative 9 to the second power is positive 81. Those first three examples, none of them had a leading coefficient. So now on example D, I'm introducing that leading coefficient. And what do we do now? Well, that's where we come up to this rule over here on the margin. To find the b, we take the middle term and divide by 2a, and then to get b squared, we square that. So in other words, that middle term is supposed to be 2ab. So let's take this and divide by 2a. Well, what's a? Well, in this case, a is 2 because the square root of 4. And so divide this by 2a, we're actually dividing by 4, and so that gives us 3, and 3 squared is 9. And if you don't believe me, then take a second to see if this squares out. So 2x minus 3 quantity squared, if we multiply that out, we get 4x squared minus 6x minus 6x. Well, minus 6x is 12x, and then plus 9. Okay, because that was only one example, I thought we ought to do maybe one more and think about, okay, I added that in the last minute, so if you already saw it in the video earlier, you might know what it is, but let's just talk about it anyway. Do you see that a is 2a is 6? And so we're going to take 30 and divide by 6. 30 divided by 6 gives us 5. So over here, what do we have? 25. All right, that is the pattern. And like I said, it's kind of a mental rhythm to get into to figure out what that pattern is. Most of what we are going to do is going to be like examples A, B, and C, where there is no leading coefficient. There might be a time or two that we get into examples like D or E, where we have a leading coefficient, but mostly we're going to stick with A, B, and C. All right, let's look at how we do this then. I think I'm going to go ahead and uncover the steps over here. Well, the first step is to subtract the constant from both sides to set up a squared plus 2ab plus blank. In other words, that's exactly setting up like we are up here. We just want to have a blank. Well, remember f of x means y. So if it's okay with you, I'll just call that y instead. Okay, I'm going to subtract my 11 and move it over to the other side. And the reason I did that is now the problem looks like the ones we just did, where we have to fill in the blank. Can you see what's going to fill that blank in? Well, it's going to be a 16. Now the problem is if you added a 16 to the right-hand side, we also have to add 16 to the left-hand side. And so now on the left, we have y plus 5. And on the right, we're going to factor this because it is a perfect square. And so this factors down to x plus 4 quantity squared. Now we want it to be in standard form, and I think you can probably already see what to do next. The next thing to do is move that 5 back over. So I'm going to subtract 5 over here, subtract 5 over here, and so my answer is y equals x plus 4 quantity squared minus 5. That is the same exact form as x squared plus 8x plus 11. Not the same form, but it's the same equation. Different forms, same equation. If you graph this one on Desmos, you would get the same graph as this one on Desmos. All right, let's do another example. Number 2. Once again, let's say this is a y. Let's subtract that 18. All right, we subtracted 18. What goes in the blank? Half of 10 is 5. 5 squared is 25. Now, if we add 25 on the right, we must add 25 on the left also. Anything you do to the right-hand side, you have to do it to the left-hand side also. So on the left-hand side, when we combine like terms, negative 18 plus 25 is y plus 7. On the right-hand side, I want to factor that, make it into a perfect square. The last thing is going to be to subtract that 7 from both sides. And so my answer is y equals x plus 5 quantity squared minus 7. And then I'm done. I uncovered that first step a minute ago. Let's go ahead and take off the rest of those so you can copy those down. All right, let's look at this next example. And now I'm including graphs and table of values because the whole reason we do completing the square is so that we have something in vertex form, and vertex form is easy to graph. So as we're doing this, we need to go back to graphing and figure out how to graph these. I'm bringing a table of values again because, once again, it never hurts to have a table of values. One thing I can automatically see here is my y-intercept. My y-intercept is going to be 0, 10. That might be worth putting in my table of values. Might be worth going ahead and graphing that so I know what that is. I do need to do completing the square. To start completing the square, I'm going to subtract my 10. Now that I've subtracted my 10, I need to figure out what goes in the blank. You have to take half of this, so 3, square it. Okay, 9 goes in the blank, but if I add 9 over on the right, I also have to add it to the left. So actually on the left, I now have y minus 1. On the right-hand side, I can factor this to a perfect square. My last step is to move that 1 back over where it belongs. And now I'm in vertex form. In vertex form, I know what the vertex is. I can put that in my table if I want. It's negative 3, 1. So I'm going to go ahead and plot negative 3, 1. Notice this does not have a leading coefficient. So as far as the 1, 3, 5 goes, it's just 1, 3, 5. So I'm going to go up 1 over 1. I'm going to draw in my axis of symmetry. It helps me with graphing symmetrically. So I went up 1 over 1. I need to go up 3 over 1. And then up 5 over 1. And notice that when I did that, it did meet the y-intercept that I had from before, which is helpful to confirm that's the right answer. So my graph is going to look something like this. That is an example of completing the square to change the equation from standard form to vertex form. We can graph it in vertex form. You can also graph it in standard form. It's just so much easier in Vertex form. And this is a way that we are using to graph, but some people use it to solve equations as well. Now, we won't really get to that very much, but some of you might have seen that before or might, find that as you're learning, and you can use it to solve equations as well. Now, example number 4 is throwing us for a loop because it has a negative in front. And so first thing I need to do is divide everything by -1. And so what I'm going to have is I'm going to have negative y is equal to positive x squared plus 10x plus 19. Eventually, we're going to have to move that negative back over to where it belongs because we want the y by itself. But for now, that's where we need it so we can do completing the square. I'm going to subtract my 19. Now that I've subtracted my 19, I need to fill in my blank. And if I add 25 to the right, I need to add 25 to the left. So I added my 25. That gave me negative y plus 6. And I factored the right-hand side to give me x plus 5 quantity squared. I now need to go and move my 6. Let me start with that. I've run out of space, so I'm going to come down here. So I have negative y is equal to x plus 5 quantity squared minus 6. Notice I still have my negative hanging around. I need to get rid of it. So now I'm going to go ahead and divide both sides by negative again. And let me remind you how that works. If you're going to divide by -1 here, you end up with a positive y. That's what we want. On the left-hand side, this is going to make it a negative out front and a positive 6. It does not change the sign in the middle because we put the negative out front, which is going to take care of all of it. So that's why that negative is out front. Don't change the sign to a plus 5. So now we're done, and we have our equation back into vertex form. From this equation, we can see that our vertex is at -5, positive 6. Let's go ahead and graph that. You might see from the original graph that our y-intercept is at -19. We're probably not going to get there, but it's going to be somewhere down here. Our leading coefficient has a -1, so it's going to go 1, 3, 5, but upside down. So it's going to go down 1, down 3, and down 5. And so I connect my points. I'm going to get something like this. This parabola will continue down and eventually hit 0, -19. If you needed some more points in your table just to make you feel comfortable, you could put that 0, -19. And don't forget, you can always just plug in numbers. Plug in any numbers you want. Now in this case, because my vertex is over here in the negative quadrant, I probably don't want to choose any positive numbers because it's going to take a while to get over there. But I could choose something like a -4 or a -3, something like that. So if you wanted to plug in another number, you could do that and see what you got to come out. Completing the square has a lot of steps to it. It's a really long process, and it is not one that's real easy to memorize or necessarily intuitive all the time. So that's why I wanted you to see these steps, get these steps written down, and we'll do some practice in class. We will continue to work with this, but make sure that you at least understand these couple of examples that we've done here on the video. The ones in the middle just set it up for you, and then some of these showed you how to do the actual problem. If you need to rewind it and look at some of those examples again, make sure you do that because, like I said, this is not an easy process and it's not necessarily intuitive and it's new to us. So make sure you rewind as much as you need to get the full understanding, and then we will do some practice in class.